Hi, I'm Macy from the Bard College Center for Civic Engagement, and today I'm going to show you 3 experiments using pennies to show us a bit about chemistry. Pennies made before 1982 may react better in the first 2 experiments. For the first experiment, you're going to need a non-metal bowl, salt, white vinegar, and a penny. You're going to want to start out by pouring about a 1/4 cup of vinegar into your non-metal bowl and then mixing about a teaspoon of salt into it until it's dissolved. Then you want to put your penny into the mixture, leave it there for 30 seconds, and then remove it. You can clean it off in a paper towel or something like that, and you will see that your penny is bright and shiny. The reason that the penny comes out looking shiny after 30 seconds in the vinegar and salt mixture is because the oxygen in the air and the copper in the penny react together to form an oxide that makes the pennies look dirty. Vinegar is an acid which breaks down that copper oxide, and then vinegar works better as an acid when it's mixed with salt. For the next experiment, you are going to want to use 2 containers with a lid, your salt and vinegar mixture that you just made, plain white vinegar, paper towels or cotton pads, and 2 pennies. You're going to want to fit your paper towel or cotton pad to the bottom of your first container and then pour a bit of white vinegar on top of it. Then you want to take your penny and put it on top of the paper towel, then screw on your lid to the container. Then you're also going to want to fit the paper towel or cotton pad to the bottom of your second container, but instead of white vinegar, you're going to dip it into the white vinegar and salt mixed solution, and then put your penny on top and screw the lid on. Then you want to label your containers and check on them after 1 hour. As you can see, there started to be a bit of blue on the paper towels and the penny. And then after 2 hours, as you can see, even more of a blue substance was forming. Then you can come back after 8 hours and really see the transformation to your penny. The reason that the pennies look greenish after spending many hours in the vinegar and the salt and vinegar mixture is because adding vinegar and salt to pennies dissolves the copper oxide layer on the outside of the penny, just like we learned in the last experiment. When the copper oxide layer is dissolved, copper atoms in the penny mix with oxygen atoms in the air and chlorine in the salt, which forms a blue-greenish substance called malachite. That is what you see on the penny. This final experiment requires adult supervision, meaning somebody who is 18 or older. We will be using pliers to create a notch in the penny, which can be dangerous. This experiment also requires a bit of background. Before the year of 1982, pennies were made of a metal called brass, which is composed of 95% copper and 5% zinc. Inflation caused the prices of metals to increase, making the value of the metals in the penny more than the value of the penny itself. So in the year of 1982, the Treasury Department changed the metal makeup of the penny to become 99% zinc core in the center with copper plated on the outside. For this experiment, you're going to need 2 glasses, lemon juice. You can either have bottled lemon juice or you can just squeeze some lemon juice from a fresh lemon, 2 pennies, one from before 1982 and one from after, and then pliers. With adult supervision or help, you're going to want to use pliers to create a notch in each of your pennies. Then you want to fill up each glass with a bit of lemon juice and put each of your pennies in. Now you want to return to your pennies in your lemon juice after a few days, I waited 3, and remove each penny from each glass. Observe the differences between the pre- and post-1982 pennies. As you can see, little to nothing will happen to your pre-1982 penny. Any oxidation on the outside of the penny may react with the lemon juice, making your penny bright and shinier than it was before, similar to how the vinegar and salt cleaned the penny. This is because lemon juice is also acidic, but your penny will remain whole. In your post-1982 penny, any bubbling is a sign that a chemical reaction is taking place. The citric acid in the lemon juice is made up of carbon, hydrogen, and oxygen. That will cause the zinc core in the post-1982 penny to oxidize. You may see small black particles floating in the lemon juice, and that is the zinc oxide breaking up. This process releases hydrogen from the acid, forming the bubbles that you see in the lemon juice. The oxidation of the zinc core within the penny makes it dissolve partially. If you were to do this experiment in a stronger acid, your zinc core would likely completely dissolve, leaving just the copper-plated outside. However, this is kitchen science, and the strongest acid we have is lemon juice. Thank you guys so much for watching. I hope you try out all these experiments at home. Once again, I'm Macy from the Center for Civic Engagement at Bard College.